Problem 21. An empty freight car on a level railroad track has a mass big M. A chute above the freight car opens and the grain falls down into the cart at a rate of R, measured in kilograms per second. The grain falls a vertical distance h before hitting the bed of the freight car without bouncing up. How much normal force is exerted on the freight car from the rails at a time t after the grain begins to hit the bed of the car? Assume the grain starts from rest. Solution for problem number 21. The upward normal force on the freight car must equal the total downward force experienced by the freight car. The freight car experienced three downward forces. First, the freight car's own weight, which is big mg. Second, the weight of the grain accumulating in the freight car. The grain accumulates at a mass rate r, so after a time t, the car contains a total grain mass rt. Thus, the total weight of the grain after time t is rtg. And third, the force from absorbing the momentum of the falling grain when the grain lands on the cart. Over some time interval delta t, an amount of grain with mass delta m equal r delta t falls onto the cart. The grain falls from a height h, so it lands on the cart with a speed v equal square root from 2gh. Thus, the grain carries a momentum delta p equal delta mv or r delta tv. And finally, the rate at which the momentum is delivered to the cart, or the force experienced by the cart, is delta p over delta t, which is r multiplied by square root from 2gh. Thus, the normal force, which equals the total downward force on the cart, is this one, which is answer E, and that was solution for problem number 21. Problem number 22. The bruise threshold for a fruit is the largest height it can be dropped from rest without bruising. The bruise threshold of a 0.2 kilogram apple on steel is 10 centimeters. Suppose that it always takes 0.1 seconds after impact for the apple to fully stop, and that 4 centimeters square of the apple comes into contact with the surface during the impact. What minimum average pressure is required to cause the apple to bruise? Solution for problem number 22. Solution for problem number 22. To find what is minimum average pressure required, we need to find what is the average force, because pressure equals force over area of impact. To find what is the average force, we have to find what is change of momentum, which we can find from formula impulse Ft equal change of momentum mv. Now we have to find what is speed when this apple touched the ground. That will be square root from 2gh. And finally we have this expression, which is after putting numbers we have 7100 pascals, which is answer C, and that was solution for problem number 22. Problem number 23. A train travels at 360 kilometers per hour on an almost straight track. The track is slightly sinusoidal with a vertical amplitude of h over 1 kilometer distance, as shown in a figure. If the maximum tolerable vertical acceleration of the train is set at 0.1 meters per second square, what is the maximum allowable size of h? Solution for problem number 23. Because this path is sinusoidal, we can write equation for vertical motion. That will be y equal h multiplied by sine omega t. From here we can find what is vertical acceleration. That will be negative omega square h sine omega t. And the maximum acceleration will be omega square h. And from here we can find what is maximum height. To find what is omega, we have to find what is the total period, which is time to travel this train for 1 kilometer. That will be omega equal 2 pi over t, and t equal distance over speed. Speed we have to translate to meters per second, which is 100. So we have total time or period equal 10 seconds. It means that omega equal 0.628 or height equal maximum acceleration over omega square, which is 0.25 meters or 25 centimeters, which is answer B, and that was solution for problem number 23.